Alright, so let's pick up where we left off. In chemistry, an atom usually has 8 electrons in its valence level. Due to this, atoms will gain, lose, or share electrons in bonding situations. However, in almost every case, atoms will desire to have 8 electrons in their valence shell. Valence level. There are generally 2 types of atom-to-atom bonds that occur between different atoms to form compounds. One is ionic, which involves the giving and taking of electrons, and the other is covalent, which involves the sharing of electrons. To help us show how electrons shift, we use Lewis dot structures to help show electron movement. Okay, so what's the oxidation number of the following atoms? You look at the periodic table, Mg is going to be 2 plus, O is 2 minus, sorry, P is 3 minus. Now, Cl is going to be a -1, Ne is going to say just how it is, copper is going to be Cu2 plus. So with this one right here, what you have to do is make sure that you pay attention to what the Roman numerals are, and that will tell you what the answer is. With sulfur, it's going to be 2 minus, nitrogen is going to be 3 minus, and cesium is going to be plus 1. Alright, and arrange these in order of increasing atomic mass. Alright, we got F, C, and L, I. Sorry, atomic radius, lowest to highest. 39, Ca, Sr, and Ba. 40 is going to be just how it sounds, Os and K. 41, Nck, that's how it's going to be. 42, FCl, I. 43, LiCF. 44, Ba, Sr, Ca. 45, KSO. 46, IClF. 47 is going to be I, ClF. 48 is K, Cu, Br. 49, Na, Zn, Br. Alright, when wavelength increases, what happens to the frequency? It decreases, because it is an inverse relationship. Zoom tight, my love. That was talking to my wife, not to y'all. It's creepy. When wavelength decreases, what happens to the frequency? It increases. Again, because it's an inverse relationship. True or false? Always you're moving at the same speed. True. That's the correct answer. Alright, so this one is going to be a little hard to follow. I'm going to try to make it as easy as I can. Okay? So, we analyze. That is going to be C equals 3.00 times 10 to the 8th. Meters per second. Alright, then we also know that our lambda, which is that weird looking symbol right there, equals 2.75 meters. So, we need to find our frequency, B. So we plug it in, and we know that C, we know this equation right here, C equals lambda V. And we can rearrange it because we want to get lambda, or sorry, we want to get the V by itself right here. So what we do is we rearrange it to be that lambda, V equals C divided by lambda. So then we plug it in. V equals 3.00 times 10 to the 8th meters per second divided by 2.75 meters. You plug that into your calculator, you end up finding that V equals 1090909 blah 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 blah. Now we only round it to 3 decimal places because that's what's given to us in our problem. So it's 1.09 times 10 to the 8th power, and then the unit is going to be frequency because that's the unit for, I'm sorry, it's going to be hertz. My bad. Because that's what the unit is for frequency. Alright, remember the equation. E equals h times v. Calculate the energy of a light wave with the frequency of 2.8 times 10 to the 8th. Remember that h is Planck's constant, and h equals 6.63 times 10 to the negative 31st. Okay, so with our analyzed part, we know that the h equals 6.63 x 10 to the negative 34th. And then the other thing that we know is that the frequency, which is V, equals 2.8 times 10 to the 8th. Okay, so what we do here is pretty straightforward. We just plug in our numbers. So E equals 6.63 x 10 to the negative 34th. And then we're going to multiply this by 2.8 times 10 to the 8th. Okay. Plug it into our calculator. Now, in order to do these, what you have to do is in your calculator, you're going to hit 6.63. You're going to hit the second button. That's the one at the top left-hand corner. And then you're going to hit the comma sign. And whenever you do this, what that gives you is E. So in your calculator, it looks like this, 6.63 E, and then you're going to type negative 34 in this case. So that's what it looks like in your calculator. But what it actually is saying is this number right here. You can do it where you do times 10 raised caret sign to the negative 34th. That's okay for now. But like on the next problem, if you did that, you'd get the wrong answer. And I'll tell you why. Okay? So you plug it in and you find your answer would be E equals 1.9. Okay, so an hour just lapsed. I think what I was getting at was that the answer was going to be 1.9 times 10 to the negative 25th. Now, one other way to know if you have the right answer or not is to look and see if this stuff makes sense. So basically, what am I trying to say from that? If you look at this, it's times 10 to the negative 34th and times 10 to the 8th. So what's 34 minus 8? 34 minus 8 is 25. So we have times 10 to the negative 25. Again, that's one of those ways that you evaluate to make sure that your answer makes sense. Alright, so here's the last number that we're going to do on this review. So the answer, well, let's just get into it. E equals HV. And so what we're trying to find is V. So what the formula that we're going to use is V equals E divided by H. Okay, so then that's 4.5. So V equals 4.5 times 10 to the negative 21st divided by 6.63 times 10 to the negative 34th. Now, your answer in this case is going to be 6.8 times 10 to the 12th. 12. Now, if you did it right, that's what your answer should be. Okay, and if you did it wrong, then that's because you didn't do the second E. If you did that part, then you got it right. If you didn't, you got the wrong answer. Alright, that's it for now. If you have questions,